Okay, click them all the way closed real quick for just a second. I want to go through.
My session is timed out.
Timed out. That's weird.
Oh, no.
Okay. So I want to go through one quick example, and then we're going to try something a little new. You see some new stuff here today. We're going to do a little board work today. Board work is good.
Oh, yeah.
So what board work is about, and we're not going to do this every day, but I want to do it sometimes. And I tell you, it's been great all day. It's really helped because it's allowed me to kind of see where people are making some little mistakes when we're all working on the same problem. The focus on board work is, for me, is more about, right answers are important, but it's more about how you're getting there, the steps you're taking, right? We're in the last lap before we're heading towards our first test coming up next week. And so I want to make sure that we're going to take a second look at some of the harder stuff that we've looked at recently. Make sure everybody's on track with this stuff. Even if you're not done with your homework, there's a chance, if you're maybe a little behind on your homework, there's a chance to get a little focus on some things that are important at the end of the unit. Right? Very useful for me, and I think you'll find the same thing. So I'm going to pick some problems. Today we're probably only going to get through, maybe 2 or 3 at the most, right? At the very most. And that's okay. It's a process. It's important. I want to look at a problem with you about solving absolute value equations, which is a 1.4, section 1.4 problem. And I've got one of those for you all to do. And then I got a couple more problems from 1.5 that I'll turn you loose on also. And kind of make the rounds, and we'll talk about this stuff. So let's go through one of these together first, real quick. Solving an absolute value equation. So what do we have to do if I'm solving an absolute value equation? What's the very first thing? Think of the process here. What's the first thing I've got to do? Okay, good. And isolating the absolute value is what we're accomplishing, right? Whatever it takes to do that. We got to do some algebra to isolate the absolute value. So there's the first part. We got to isolate the absolute value. Think of it as one big variable, right? To get that variable by itself, we divide each side through by 2. I want to highlight a couple of mistakes that I've been seeing pretty consistently from people. Not everybody by any means, but I see this a fair amount, and tell me what I'm doing wrong here. I got it. Okay, I got to divide the whole side by 2, right? And let me defend that. For now, I want Chromebooks all the way closed, and I want phones and earbuds and all that stuff away, please. I'm going to only grab your attention here for probably 5 or 6 minutes, and then you're on your own. But I really want everybody with me on this. So I'm going to just justify why that is, why we can't do that. Here's a way that might make it, if you're having a hard time conceptualizing that, here's a way to think about it. What if I had something like, let's say, 12 plus 4, no variables, equals 16, okay? Now, if I'm going to divide, tell me what's wrong with this. If I'm going to divide this whole side by 2, and I divide just that term by 2, what happens? I end up with the statement 6 plus 4 equals 8, which is not true, right? What did I do wrong? I didn't treat both sides of the equation equally. When I do something to one side of the equation, I have to do it to the entire other side of the equation. I can't just do things to parts of equations, even if I did something similar like this. This also is not okay. What if I had 12 plus 4 equals 10 plus 6? I can't even do something like that. You might say, well, I'm dividing the first term in each side by 2. That seems like I'm doing the same thing. It's not. It's not, because this term represented a different proportion of the whole left side than this one did. Still not okay. I still get a wrong answer. Right? I still get 6 plus 4 equals 5 plus 6, which is not true. Right? I have to do the same thing to everything on both sides of an equation if I'm going to keep the equation valid. Okay? So I have to divide this whole side by 2, not just the first term, the whole thing. That's useful because I can cancel the 2's here, and I end up with the absolute value. And make your absolute value bars a little bit taller than the numbers in the variables, so you can, you don't think it's a 1, right? Absolute value of 4x minus 15 is equal to what? If I divide the whole right side by 2, what do I get? There you go, 5x plus 5. Okay, good. We isolated the absolute value. Okay, that's the first part of the process, first stage. What's the next stage?
Make the 15 and positive, right?
Okay, good. I'm gonna say it again.
Make the 15 and positive.
Oh no, I can't do that. Can't do that because, and there's a real temptation to do that because it's inside absolute value bars. But if I did that, if I change that 15 to a positive 15, that's going to change the values of x that make this equation true. Okay?
Okay, then add 4x minus 15 equals 5x equals 5, and 4x minus 15 equals negative 5 minus 5.
Bingo. There you go. So now we're going to trade the absolute value equation for two regular equations, right? Because remember what I said, it's been like a week and a half ago. We can't do any algebra ever inside the absolute value bars. It's off limits. So I've got to get rid of them. And the way I get rid of them is once I isolate the absolute value, I'm going to set up two regular equations. And the way I do this, remember, is whatever's inside the absolute value bars, in order for this to be true, either has to equal positive 5x plus 5, not 15. Right? That's one thing that could happen. Or it could equal whatever's inside could equal the negative of that because the absolute value makes it positive, right? So whatever's inside equals, now what's wrong with this? You tell me what's wrong. Negative 5x plus 5.
You don't get a negative
The whole thing has to be negative, right? Not just one term. I got to make the whole other side of the equation negative. So I've got to do something like that, don't I? Right? Negative everything, and then distribute the negative. Okay? So I end up then with two equations. And I can solve both of those. So the first equation over here, what do I do to isolate x in this equation? I got to combine like terms, I guess. Where am I pushing the variables? To the right, good. I want to make a positive number of variables. So I'll subtract 4x from both sides. Good. If the variables are going right, the numbers go left. Okay, so that's going to give me then, I'm going to get negative 20 equals x. Okay, one possibility. Or, how about over here? Well, I got to distribute, don't I? So I've got 4x minus 15 equals, if I distribute, negative 5x minus 5. Where am I pushing the variables this time? To the left. Good. Variables go left, numbers go
Right.
So I'm going to get 4x plus 5x is 9x. Negative 5 plus 15 is 10. Last step. Good. And so I end up with my other possibility being x equals 10 ninths. Done? No. I forget to do. Check them. I got to check them. When I'm solving an absolute value equation, I could get extraneous solutions, right? We don't have that problem for solving regular linear equations, but when we're solving absolute value equations, we could get false solutions, so we got to always check them. So here, and I want you, when you're doing this for your board work, I want you to go ahead and use the Desmos Scientific Calculator. And it's to your advantage. On the tests, the first test, we haven't done anything with graphing utilities. With graphing, using the Desmos graphing utility or your TI-84s. We will. Pretty soon, we'll get into some new material and we'll start using those. And so in the future, paring down next, units after this one, there will always be two parts to the test. There's going to be a graphing utility part where you can use all the tricks of Desmos or your graphing calculator. And I want you to, because that's a big part of what you do in college, is knowing how to use those things. And then there's another part where you don't have access to your slick graphing utility and you have to just do regular algebra. But on that one, even though you can't have a graphing calculator, I will let you use the Desmos Scientific Calculator always, right? which is, you might as well know how to use it, because it's always a tool you're gonna have. So, let's review one more time how we do this, because this is what I want you to do today. I want to see you actually doing this so I can verify. You can prove to me that you know how to do this stuff. We're just going to pull up Desmos. And we're going to check both of our solutions in our original equation. And let's make this look a little better. So there's our original equation. And the solutions were, possible solutions were, remind me, wasn't it negative 20? So we'll check both of those. Okay? So let's just go through this process yet again. I want you guys to be doing this. So remember, what we want to do is we want to be able to plug in negative 20 to the left side of the equation and see if that number matches what we get when we plug it into the right side. So one way you can do this is you can start off with just x's, and this might be handy. So we'll do 2 times absolute value. Well, there's my button for absolute value. It's a real common one right there. Absolute value of 4x minus 15. Okay? There's the left side. The right side is 10x plus 10. Okay, now all I got to do is go up here and I'm going to replace the x. So I'm going to highlight the x and I'm going to replace it. Now this is really important. What I saw earlier in the day with people a lot of times is they forget to put the number in parentheses. That's really important to do. Later on in the class when we do different kinds of functions, for example, if we're taking a number to a power, if you take a negative number to a power and you don't put it in parentheses, you're going to get the wrong answer, right? So it's always safe. Always want to put any number that you're plugging into a function in parentheses. So instead of the x, we're going to plug in a negative 20. Down here, instead of the x, I'm going to plug in the quantity, so in parentheses, negative 20. What do I see? On the left side, I get positive 190 when I plug it in. On the right side, I get negative 190. So is negative 20 a solution? It is not. You're right. It's not a solution. So that's one that we can cross out. Okay?
Seth Williams, please come to the office. Seth Williams.
How about 10/9? We don't have to redo everything. All I've got to do is go back to my parentheses where I'm plugging in numbers and just replace the negative 20 in both expressions with 10/9. So there's on the left side I get this decimal. On the right side I get the same decimal, right? 21.1 repeating. And whenever it gives me the option to convert to a fraction, it gives me that button. It means that the answer is rational, so it can be written as a fraction. Might as well hit the button so it looks easier, right? I get 190 ninths on both sides. So what's the conclusion? Is 10/9 a solution?
Yes.
Yes, it is. So that one checks out, but only one of them works. What I was seeing a lot on the assignments, people were doing good work, and they're going through all the hassle of getting both solutions, but they're just forgetting to check to see if one of them is extraneous or both of them, right? Make sense? Okay, so everybody grab